Welcome to part 3 of 6.3 notes. We're talking about dividing rational expressions. In this video, there's a 4-step process, but it's very similar to multiplying rational expressions. We're going to go ahead and start. So the step 1 is factor. So if we're looking at our first example, we're always going to want to factor out anything we can. Now, technically, we could factor the 6 into something, but for the sake of just whole numbers and integers, we don't really care about factoring them, so we can really skip that first step on this first example. Number 2, reduce. Now, this is very important because it really saves you a lot of time. If you can reduce the fraction, reduce the rational expression first. So I'm going to rewrite this problem as well, first off, let me identify what I can reduce by. I can divide both the top and bottom by 2. So I'm going to rewrite this guy as 3 over 4 divided by 2 over 3. Okay, so that's my rewritten expression that's reduced. So factor I didn't have to do, check, reduce, check. Now, this is the part where we're just essentially dividing normal fractions. So if you're good with dividing normal fractions, you're good with this step. Change the reciprocal and then multiply is the basics. Now, a lot of people like to refer to this as keep, change, flip, or stay, change, flip. Okay? Keep, change, flip it, bop it, twist it, pull it, whatever you want to call it. That's what we're going to do. Okay? So this is the keep part. We keep the first fraction when we're dividing fractions. So that's the keep part, just in case you guys are wondering. Keep. The change part is we're going to change the division sign into multiplication. So we're going to change to multiply. And then the last part is flip it. We are going to flip this to the reciprocal. Dividing by a fraction is the same thing as multiplying by the reciprocal. So we are going to flip to reciprocal. Okay, so flip to reciprocal. What does it look like when we're done? It's going to look like 3 over 4 times, changed it, and then flip it 3 over 2. That's simple. And now if a lot of times you can reduce again, what you can do is what I call cross-canceling, but there's nothing to cancel here. There's nothing can be reduced. So we're just going to go ahead and multiply. Last step, hold on, we changed, check. And now we're on to multiply. So we multiply top times top, bottom times bottom. What do we get? Well, we get 9 over 8, and that is reduced as possible. If you're really good with making sure you cancel along the way and reduce along the way, you won't have to reduce at the end. So 9 over 8 is as reduced as it gets. Okay, we're going to erase these check marks. Hold on. Done. We did all 4 of these steps. We're going to go ahead now and try it again with example number 2. Okay, now we have some expressions, we have some binomials, we have some variables. Gets a little tougher now. So we are actually going to do our first step, which is factor. Now, we got to factor each numerator and denominator separately if possible. So our first numerator, we can. We're going to factor out, let's look at the numerical coefficients. We can factor out an 8 of those. There's no other variables, so we're going to leave the k alone. No factoring out of the k here. And this is going to be k, 8k divided by 8 is k. Then we have 16, keep the sign the same, divided by 8 is 2. So that's what the top's going to look like. 3k cannot be factored any further. We're going to keep this sign the same for now. And now we're going to look at this guy. Can we factor out something from here? Yes, we can. The 3 and the 6 have a common coefficient, common factor, which is 3. What's left is k minus 2 again, over 4k squared, cannot be factored any further. Next up, so that was factor. Check. Now reduce. Can we reduce anything? I'm not seeing anything that's going to cancel in the top and bottom. And when we're talking top and bottom, we're talking about each fraction by itself. So if we're looking at each fraction by itself, there's nothing to cancel in the top and bottom. So really, there's nothing to reduce this time. Change to reciprocal. All right, now this is the keep, change, flip. We're going to keep this. We're going to change, I used this color last time. We're going to change this, and we are going to flip this. I got to change color now. Dang it. So we're going to flip this, okay? Keep 8 times the quantity k minus 2 over 3k. Change to multiplication. flip. We need to flip this guy now. 4k squared over 3 times k minus 2. Cool. So we're done with change to reciprocal. Boom. Now we multiply. Now, actually, this is what I wanted to highlight earlier. We can do some canceling before we multiply. If you want, just go ahead and multiply top times top, bottom times bottom, and reduce at the end. But I personally like to cancel before I multiply. What can I cancel? Well, I see I have a k here, and then I have a k squared here, so it means I can cancel out one of those k's, leaving just k. Now, next thing, I notice that I have a k minus 2 in parentheses being multiplied, and then a k minus 2 in parentheses. Those can cancel. And I think that's it. So now what we're going to do is multiply what's left. We have 8 times 4 times k in the top, and then we have 3 times 3 in the bottom. This simplifies to 32k over 9, and it can't simplify any further, and we get our final answer. Now, let's say we didn't do that. We would get 32k times k minus 2 over 9k k minus 2. Obviously, or sorry, forgot the squared. That was there originally. Obviously, we can do the same thing here after we multiply, but I just think it's easier before. Most of the time, it's easier to do it before in this step. Okay, so then we're done. We're done with multiplying, and this is our final answer right here, 32k over 9, and that's how you divide rational expressions. Thanks so much for joining me. Be sure to check out the next series of notes, which is section 6.2.